To begin, we need to remember how to simplify square roots. Number 1, we have the square root of negative 144. Well, remember that the square root of 144 is just 12, so the square root of negative 144 would be 12i. That's an imaginary 12. On number 2, we have the square root of 216. Now, if I type in square root of 216 into my calculator, I get a pretty yucky looking decimal. So this is one that we want to simplify. So what we want to do is we want to think of a perfect square that goes into 216. So using my calculator, I see that 216 is divisible by 4. I also see that 216 is divisible by 9. And I'm going to guess if it's divisible by 4 and by 9, I'm going to guess it's also divisible by 36. So since I don't know exactly what the square root of 216 is, I want to break this down and think of it as 36 times 6. And remember here we're taking the square root of these values. Now, even though I didn't know the square root of 216, I do know the square root of 36 is just 6. So this leaves me with 6 square root of 6. 6 square root of 6 is the same thing as the square root of 216. It is just simplified. Number 3, we have the square root of negative 148. We know that the negative tells me it's going to be an imaginary number, but the square root of 48, if I type in the square root of 48 into my calculator, again, I get a pretty yucky looking decimal. So this is another one that I want to break down. So I want to know what perfect square goes into 48. So I can use my calculator and I see that 48 is divisible by 4. 48 is also divisible by 16. And to simplify it the most, we want to use the largest perfect square. So instead of thinking of this as the square root of negative 48, I want to think of this as negative 16 times 3. And again, I'm taking the square root of these values. And even though I don't know the square root of negative 48, I do know the square root of negative 16 is 4i. The I is there because this is an imaginary value because of that negative. The 3 will stay under the radical. Now that was a very quick review. If you need a more detailed explanation of simplifying square roots, please go back and see the previous lesson. What we're going to do in this lesson is solve quadratic equations using square roots. On number 1, we have x squared equals 6. And right off the bat, most students will tell me, okay, well, you have x squared. If you want to get x by itself, all you need to do is take the square root of both sides. That's exactly right. If you take the square root of a square, it'll cancel out, and that leaves you with x equals 6. Now, if that's the only answer that you write down, you will get half credit on that problem. It is true that 6 squared is 36 because positive 6 times positive 6 is positive 36. But remember that negative 6 squared is also positive 36. Negative 6 times negative 6 is positive 36. So when you're solving quadratic equations, keep in mind that you should always expect to get 2 answers. Whenever you take the square root of a number, remember that there's 2 solutions. The square root of 36 could be positive 6 because 6 squared is 36, but it could also be negative 6 because negative 6 squared is positive 36. Number 2, we have 3x squared minus 11 equals negative 158. Here we want to solve for x. I see my variable right here. So we want to take apart this problem. We want to cancel out one number at a time until the only thing left is just x. Now remember, you want to start with the things that are not attached and work your way towards the variable. So in this problem, I would start by adding 11 to both sides. So negative 158 plus 11 is going to be negative 147. So we'll bring this down. 3x squared equals negative 147. Next, to get x by itself, I'm going to cancel out the 3. We'll simply divide by 3 on both sides, which leaves me with x squared equals negative 49. From here, we want to get x by itself. To get rid of that square, we will take the square root of both sides. And we know the square root of negative 49 is an imaginary 7, 7i. But keep in mind, like example number 1, when you take the square root, you should always have a positive solution and a negative solution. So what I'm going to do is put a plus or minus in front. So that's plus or minus 7i. That's really two answers. The value of x could be a positive 7i, or the value of x could be a negative 7i. So every time that you solve a quadratic equation, you should be ending up with two possible solutions. All right, last one, number 3. We have 3x plus 5 squared equals 49. Now this one's set up a little bit differently than the previous problem. This time the 3x plus 5 is locked inside those parentheses. On the very outside you have that exponent. We need to get rid of that first. So the very first thing I'm going to do with this problem is take the square root of both sides. That way the square and the square root cancel out on the left. We have 3x plus 5 equals square root of 49. Square root of 49 is 7, but don't forget when we're solving these problems we should get two answers, so we have to put that plus or minus. Square root of 49 could be positive 7 because 7 squared is 49, but it could also be negative 7 because negative 7 squared is also positive 49. So here we got to be really careful with this plus or minus. We actually have two equations that we need to continue to solve. So we're going to have one with 3x plus 5 equals positive 7, and we'll have another equation with 3x plus 5 equals negative 7. And we're going to solve both of these equations, go through and just get x by itself. So here I would subtract 5, and then I would divide by 3. So I end up with one answer is 2/3. For the second equation, I'm going to go through the exact same process. Just remember that it's a negative 7 over there. So whenever we subtract, negative 7 minus 5 is negative 12, and then we can divide by 3. That is the end of this section of 3.9. To see the video over solving using the quadratic formula, please see the next video.